The canals of Paris, the Canal Saint-Denis, the Canal Saint-Martin, and the Canal de l'Ourcq. These three waterways represent an exceptional industrial heritage. With its source nearly 100 kilometres from the capital, the Ourcq Canal crosses 2 regions, 5 departments, and 43 municipalities before reaching Paris, where it meets the other 2 canals and flows into the Seine. These waterways have shaped the face of the capital since the 19th century. Their construction was an extraordinary challenge, a titanic project that lasted more than 20 years.
They did it with shovels, hoes, wheelbarrows, and prisoners.
This hydraulic megastructure contains many secrets, totally unknown to the general public.
Very few people know about this hidden part of the Canal Saint-Martin.
As well as feats of engineering, like these oculi, which are still used today.
It's designed as something that will stand the test of time. It has to last and keep on going for decades and centuries.
For 200 years, their mission has been to carry water and goods. But to make them navigable by boats, the engineers had to overcome immense technological challenges, such as building 26 locks, one of which is 10 meters tall, the height of a 3-story building.
This lock had a distinctive feature. It was the deepest in Europe because it had a 10-meter rise.
Swing bridges had to be built. One of the largest water wheels of the time, and the first hydraulic lift bridge in Paris.
By applying 3 bars of pressure, that's to say the pressure of tap water, you create an imbalance which makes it possible to raise the bridge.
Today, these canals are monitored 24 hours a day to make sure that their installations are completely safe.
If a lock doesn't work, no boats can get through. It's very simple.
The maintenance of these 130 kilometers of waterways is essential to ensure that they run smoothly. We're going to show you all the inventions that were used in building these structures. How the architects and engineers succeeded in harnessing the water to distribute it more efficiently. And how the canals reinvented themselves to stay at the forefront of innovation. We're about to reveal the secrets of the canals of Paris. Just like the Eiffel Tower and the Louvre, the canals of Paris are major landmarks in the French capital. 3 in number, the most emblematic is the Canal Saint-Martin. Built in the heart of Paris, connecting the Seine with the Bassin de la Villette, it flows through the city for 4.5 kilometers, with more than half of its journey taking place in secrecy beneath the streets. It's used for recreational boating and attracts tens of thousands of tourists every year. The second canal, the Canal Saint-Denis, is more than 6 kilometers long and connects the Bassin de la Villette to the Seine. It's mainly used for carrying goods. Finally, the Canal de l'Ourcq, to the northeast of the city, is the longest and oldest of the 3 canals, flowing in from almost 100 kilometers from Paris. Although they're part of daily life for tourists and Parisians alike, the canals remain largely unknown and hide amazing secrets.
Whenever Parisians see the canals, they're seeing a mystery. I see a lot of Parisians gazing at the canals. They don't always know what they're for. They don't know where they've come from. But finding out about the history of the canals, we're discovering another aspect of the history of Paris.
But what are the canals for? Why were they built? To find out, we have to go back to the 19th century. At the time, the population of Paris was growing rapidly. And there was a problem. The Parisians had no fresh water. The water they drank came from the Seine, which was far from clean.
Paris had no sewers back then, so all the polluted water was discharged into the Seine. This water was then pumped back and distributed as drinking water throughout Paris, which caused a great deal of pollution and the massive epidemics that hit Paris.
Napoleon Bonaparte, who was then first consul, wanted to boost his popularity. He therefore decided to improve the inhabitants' living conditions.
One day Bonaparte was walking with Chaptal, the prefect in Paris, and said, "What can I give the Parisians that would please them? What would be useful to them?" And Chaptal reportedly replied, "Water."
Napoleon then returned to some old architectural projects with one aim in mind: to provide the Parisians with drinking water from the countryside. To do this, he looks 66 kilometres northeast of Paris as the crow flies. There flows a river, the Ourcq, which is easily accessible. This canal would have another vital function.
It was decided that the canal would not only bring drinking water, but that it would also be used for transporting goods with which to supply the capital. So this was the distinctive feature of this Parisian canal.
A feature it retains 200 years later. It's actually the main and the most spectacular activity on the canals. Every day, huge barges filled with tons of sand and concrete use this hydraulic network. And it's these immense metal structures that allow them to complete their journeys. The locks. In total, the 3 Parisian canals have no less than 26 of them.
The locks enable boats to travel from a high point to a low point. So, for example, if we take the Canal Saint-Martin, we start from the Bassin de la Villette, which is the high point and which is a reservoir for the canals as well as for drinking water. And you go from a high point to a low point, the Seine.
Locks work on the principle of communicating chambers. For a boat wishing to go down the canal, the upper gates of the lock are opened. Once the boat is entered, they're closed, so that the watertight chamber can be gradually emptied until all the water is the same as the water downstream, on the other side of the lower gates. All that remains is to open these gates so that the boat can continue on its way a few meters lower down. It seems simple, but there was a problem that had to be solved in order to avoid any danger. Contrary to what one might think, it would be totally impossible to open the gates all at once because of the enormous pressure placed on them by these huge volumes of water.
The force of the water is so great that if we opened the gates of our locks suddenly, they would burst. They would be torn from their pivots. So much water would be released that it would flood the whole neighborhood. The roads, the cellars of buildings. It could do enormous damage.
A key element was installed in the first locks from the start of their construction in the 19th century: gate paddles. These panels slide up and down over holes in the lower part of the gate. They act as valves to control the flow of water and to balance the levels on both sides. Another solution was found in the design of the locks to control the pressure of the water exerted on the gates.
The lock gates in the Canal Saint-Martin aren't straight. They're at an angle. This is to absorb the pressure of the water, which is in the order of several tons.
Every time a boat goes through, depending on the size of the lock, up to several million litres of water are used. But water pressure isn't the only danger facing locks.
The force of the water is considerable. If the lock doesn't close properly, because a tree gets in the way of the gates, for example, the gate will be damaged. It can even be torn off.
To confront all these dangers, the locks have been perfected and modernised over time. To open their gates, the simple paddles were soon replaced by hydraulic systems.
Today, we've given up the idea of paddles incorporated into the gates. They're a bit fragile, they can get stuck. They create a lot of eddies around the gates, so they can get damaged.
We're constantly evolving in terms of operation, whether it's filling or emptying the chambers, or opening and closing the lock gates.
They're much more efficient. They create eddies that are spread out all over the lock, so there are fewer of them. It's faster, it's more efficient, and today it's the principle that's universally adopted in all the major locks around the world.
These locks continue to operate as efficiently as they did over 2 centuries ago, and are a priceless legacy. They were installed when the first of the 3 canals, the Canal de l'Ourcq, was built. The Canal de l'Ourcq. This was a huge waterway, 96 kilometres long. It was the centrepiece of this hydraulic network. It was the starting point for the whole canal adventure, with 6 locks and 3 swing bridges. It was the largest of the 3 canals, and its construction was a titanic challenge at the beginning of the 19th century.
It was possible to transport drinking water and to carry goods, but only under 2 conditions, and these conditions were that the current was fast enough and that there were very few obstacles.
But in this region, none of these conditions could be met. The geographers would have to reach new heights of ingenuity to direct the waterway towards Paris. The slope of the future canal had to be meticulously calculated. To achieve the ideal current, the engineers created large loops.
It also required careful levelling, being able to take precise measurements so that the canal wasn't too steep, that the slope was just sufficient.
The source of the Canal de l'Ourcq is just 66 kilometers from Paris as the crow flies. But these loops made the waterway much longer. It ended up measuring 96 kilometers.
Looking at the map, these incredible loops are quite amazing. It simply follows the twists and turns of the Marne.
The workers had a colossal task ahead of them. First, they had to dig a wide trench, 2 meters deep, with shovels and pickaxes. To prevent the sides from collapsing, the banks were then strengthened. Posts, 2 to 3 meters long, were sunk deep into the bottom of the canal, making it possible to set what were known as fascines in place. The fascines also acted as buffers between the boats and the bank.
They wove small tree branches in and out of these posts. They perform exactly the same function as a safety rail today. The advantage of this is that since the inland waterway wasn't motorized, when a boat wanted to stop, it would run alongside the bank. The good thing about these structures was that they weren't going to damage the hulls of the boats, which were made of wood. The boat would slide along the bank as though sliding along a rail.
The canal also had to be made watertight. The bottom of the cut was therefore lined with a layer of clay, 15 to 20 centimeters thick. It was only after this operation that it could be filled with water. On some sections, the existing bed of the River Ourcq was used, but it still had to be developed over several kilometers to make the canal navigable in areas upstream, such as in between Mareuil-sur-l'Ourcq and Port-au-Perche. To turn the river into a navigable waterway, its natural banks had to be straightened and levelled. Again, fascines and posts were used to strengthen them. A towpath for pulling boats by horsepower was also created on one of the banks. In the 19th century, there was very little mechanization involved in large-scale earthworks.
The tools were much more rudimentary than they are now. It was done with manpower, with elbow grease, with shovels, hoes, wheelbarrows, etc.
The project was so vast that they even called in a very special workforce.
Most of the workforce was composed of prisoners from the Napoleonic Wars. There were a lot of people sentenced to forced labor who were employed on the construction sites and made available to the contractors, whose job it was to feed and house them. So there was a lot of manpower. The work actually went relatively fast.
Despite the complexity, 3 years after the launch of this project, the same construction techniques were used to build a second canal north of Paris, the Canal Saint-Denis. But the construction of these canals would create new constraints.
They were going to have a huge amount of water arriving in Paris that they would have to store, so they built a reservoir to receive it, which is the Bassin de la Villette.
The Bassin de la Villette, a spectacular structure. It's actually 2 basins, covering 70,000 square meters in total, 7 hectares, the equivalent of 10 football fields. The largest artificial lake in Paris was filled with water on December 2nd, 1808. In the 19th century, this basin was mainly used as a reserve of drinking water for Parisians. a reservoir of 140 million litres of water, the equivalent of 56 Olympic swimming pools. Its perfect location soon made it strategic. Situated in the northeast of the capital, it became the hub of the whole canal network.
The Bassin de la Villette was created in the upper part, which meant that the water could be collected, so it was a large open-air reservoir.
Once the 3 canals had been built, the Bassin de la Villette would be tasked with redistributing the water coming from the Canal de l'Ourcq to the Canal Saint-Denis and the Canal Saint-Martin. It was a unique hydraulic infrastructure, thanks to which the French capital expanded at the end of the 19th century. Warehouses were built along its banks. The port of La Villette became quite simply indispensable.
It enabled considerable industrial development in Paris. At the end of the 19th century, La Villette was the 4th busiest French port after Le Havre, Bordeaux and Marseille.
The construction of the Saint-Denis and the Ourcq canals meant that the architects and engineers had to take on immense challenges with technical resources that were much less developed than they are today. They would have to canalize a river over a distance of nearly 100 kilometers and build a huge reservoir, the Bassin de la Villette. But the biggest technical challenge was creating a canal in Paris, in the midst of the city's housing. The Canal Saint-Martin. At 4.5 kilometers long, in the heart of Paris, it's the best known of the 3 canals, attracting thousands of tourists every year, thanks to its cruises, its romantic views, and its leafy pedestrian areas. And yet it almost never saw the light of day. In the 19th century, this waterway was particularly complicated to build. And the main reason for this was the Parisian subsoil.
The canal is actually built on top of the old quarries, and there's also gypsum. And the problem with gypsum is that when it comes into contact with water, it becomes very soapy and slippery.
In this part of Paris, the subsoil was riddled with holes, tunnels, and quarries. It was impossible to build an infrastructure on what resembled a Swiss cheese. But the engineers found a solution. To make the canal bed, they came up with the idea of resting the burr-stone slab that would form the bottom on a forest of stakes, each driven 10 meters into the ground. The role of these solid vaults was to separate the canal from this unstable subsoil. It was a particularly difficult task. But the subsoil wasn't the only problem. There was a difference of 25 meters between the Bassin de la Villette in the north and the Seine in the south. The only solution the engineers could find was to build locks. But it would take no less than 9 of them to allow the boats to descend in safety to the Seine. It was an ambitious project, which soon fell victim to its own success. Warehouses, glassworks and flour mills soon gathered on its banks. Thanks to the transport of freight on the Canal Saint-Martin, this district of Paris soon experienced exponential industrial development. Starting off as a centerpiece, the canal eventually became an obstacle that cut many districts of Paris in two.
Shipping took priority on the canal. In other words, when a boat arrived, road traffic was stopped. Very soon, there were monstrous traffic jams in Paris, because with the increase in traffic, the bridges were closed more often than they were open.
In fact, the canal was a cleft in the existing urban structure, a very deep cleft that separated 2 territories.
The Canal Saint-Martin became a real inconvenience when Haussmann launched his great modernization projects. As prefect of Paris, he wanted to build the Boulevard du Prince Eugène, the current Boulevard Voltaire. But the trouble was, this boulevard had to cross the Saint-Martin Canal.
The engineers studied the problem and realized that the only way they could proceed with this boulevard was to build a fixed bridge.
But no boat would be able to pass under this bridge at that precise spot in Paris. So they decided to move the 2 locks that were located there and to make the canal 5.5 meters deep.
They realized that by digging down 5.5 meters for the canal, they might release miasmas, bad air, and all sorts of dangerous things, and they paid close attention to that.
To prevent the possibility of microbes spreading through Paris, they decided to cover the stretch that had been dug out. The vaulted part of the Canal Saint-Martin was the perfect answer to all these constraints.
It would also, of course, help to create continuity between the centre and the east of Paris.
The work on this covered part of the canal lasted almost a century, between 1814 and 1906. The result hides an unknown treasure in the heart of Paris.
We're at the entrance to what is known as the Richard Lenoir Vault, although the construction of the entire covered part of the Canal Saint-Martin consists of 6 vaults.
6 vaults, 6 different sections built in several stages. Structures more than 2 kilometers in length are linked together beneath the streets. Standing on the surface, it's impossible to imagine this hidden construction.
We're currently under Boulevard Richard Lenoir with these oculi, which are these openings that allow light and air into the canal.
In the 19th century, these light wells were also essential for removing the smoke from the steamboats. Today, artificial lighting has been installed for safety reasons. All of these vaults are built in limestone, burrstone, the most common stone at that time. But the last vault is an exception. Made of concrete, it testifies to the technical advancements of its time.
This vault is special because the concrete is only 50 centimeters thick and only 75 centimeters at the keystone.
It's hard to believe, but only 75 centimeters of concrete supports an entire district partly transformed into a green walkway.
Very few people know about this hidden part of the Canal Saint-Martin. They often hear noises beneath their feet when they're walking along Boulevard Richard Lenoir, but they fail to realize that in fact there's a canal running below them with boats on it.
These vaults literally transformed the destiny of the Canal Saint-Martin. It became the main axis of commercial transport in Paris until the end of the 19th century, which is why it would become imperative to modernize and replace its technical infrastructure, and particularly its swing bridges.
Basically, the Canal Saint-Martin would be an opportunity to develop techniques that were rather avant-garde for the time. These were urban bridges that had to operate fairly continuously and be able to open and close easily and quickly because there was a lot of traffic.
One of these movable bridges is a structure that's classified as a historic monument. The Grand Jobel swing bridge was built in 1885 on the Canal Saint-Martin in the 10th arrondissement. The Grand Jobel bridge has an ingenious way of allowing boats to pass through. First, a hydraulic cylinder, powerful enough to lift the bridge up slightly, takes it out of its safe position. A second mechanism then takes over. A gear wheel measuring almost 2 meters in diameter, sitting in the base of the bridge, is activated and rotates the bridge 75 degrees in order to move it parallel with the bank.
They turn it to park it to one side and free up the channel, which is the space for the boat to pass through, and then they move it back.
And then the boat can pass through. The principle's very simple. And then the same thing happens again, but in the other direction. It's raised again, it turns, and it's placed back in its trench, but in the road position.
Over time, all of these hydraulic infrastructures have evolved, benefiting from the incredible advances in technology. In the 19th century, the lockkeepers opened these gates manually. Today, everything is operated remotely from these large control centres.
You just need a control centre. On the Saint-Denis canal, for example, the locks are controlled by 2 control towers located on the canal. So you don't need to have a lockkeeper on site with his windlass to lift the bridge. It's all done remotely.
Okay, I'm filling the small chamber and setting the front gates to 45 degrees. There are cameras that allow you to see what's going on at a distance from the command post. The lockkeeper is at his post, but he's really there to check that everything is going on in the safest and best possible way.
Sitting in front of several screens, today's lockkeepers look like air traffic controllers.
Our goal is to ensure optimal navigation, almost 365 days a year, so that boatmen, pleasure boaters and cruise passengers can pass through our locks in a safe and efficient manner.
In addition to operating the locks, these lockkeepers perform an unexpected task, making sure that the water level stays the same throughout the canal system.
There has to be enough water for navigation, but it's also important to make sure it doesn't overflow.
Too much water in the canals could be catastrophic for the Parisians.
If for any unfortunate reason the Canal Saint-Martin or the Bassin de la Villette were to overflow, it would have a huge impact. The cellars of the buildings in Paris would most certainly be flooded.
To avoid such a disaster, the lockkeepers manage the variations in water levels remotely.
When there's too much water, because it's rained a lot, the lockkeeper has to release it. They open the paddles in the lock gates, I'm talking about in the Canal Saint-Martin, to direct the water down to the Seine at the Porte de l'Arsenal. These releases are performed to keep the water at a constant level for navigation and to prevent the canals from overflowing.
Despite careful monitoring, the risks remain, because some things can't be done remotely, such as unblocking the lock gates. Items that might interfere with navigation have to be fished out on a regular basis. Professional divers with specialist skills intervene in places where machines are unable to operate.
We're doing some maintenance on a lock in the Canal Saint-Denis.
It's an extremely risky mission. These divers have equipment that allows them to stay underwater for a long time.
In addition to this, we also have a communication system so that we can keep in contact with the surface.
Can you send me down the knife?
Yeah, send the line up, we'll drop it down to you.
Thanks.
It's a dangerous task, because they have to get very close to the lock gates to remove whatever is obstructing them. This is where the water pressure and the currents are at their strongest.
The problem with the locks is the risk associated with suction.
The teams have emergency equipment to help them avoid these dangers.
He has a bottle called a bailout bottle, which allows him, if there was ever a problem with the main supply, to breathe using this small bottle. In this case, we'll assume that he's in trouble and he'll come back up to the surface.
Every year, the divers remove several tons of waste from the Parisian canals. The reason this rubbish gets stuck in the locks is that it's often caught in the aquatic plants that grow in the canals. There is only one way to remove them, by using this totally unique boat, specially designed for the Paris Canal service. Originally used by oyster farmers, these boats have been completely modified for this unusual task.
A canal that's made for navigation must be able to operate not at night, but at least every day, in order to let boats through. So there's a kind of obligation to maintain it, and the need for a human presence to make everything that's necessary work.
It's a disciplined approach to keep the traffic flowing. But there still has to be enough water to fill the entire 130-kilometre route formed by this immense hydraulic network, because the slightest shortage could bring it all to a halt. This problem arose in the 19th century. 40 years after the construction of the canals, water was no longer reaching Paris in sufficient quantities. It was discovered that this shortage stemmed from an element that was essential to the smooth operation of the canals, the locks.
A lock consumes water. Every time a boat comes in and goes down, the water's drained out. That's a volume of water equal to the volume of the lock each time a boat goes through. That's a lot of water every day.
Added to this is the recurring problem of droughts. This was the case in 1865. At that time, the Ourcq Canal lacked water, an unexpected situation which threatened supplies to the capital.
The Ourcq River couldn't provide enough water to operate the Canal de l'Ourcq and the Canal Saint-Martin, so they came up with the idea of drawing up water from the Marne, because the Marne's nearby. The canal follows the course of the Marne, so they'd bring in water to replenish the Canal de l'Ourcq.
However, the Marne was 12 meters lower than the canal. Bringing in water from it seemed impossibly difficult.
So they started thinking, what are we going to do? And the answer was, quite simply, to use hydraulic power.
A pumping station was built in the spot where the Ourcq and the Marne ran closest together. But raising the water the 12 meters that separated the Marne from the canal required a lot of power. At the time, water wheels were used to power these turbines. A brilliant inventor, Alphonse Sagebien, found the solution. He designed a water wheel that was much more efficient than previous systems.
These were big water wheels, the biggest that had ever been made, 11 meters in diameter. That's almost 3 stories tall. You can see the size of them. And these wheels would have been powered by a little fall, just 80 centimeters of water from a small dam on the Marne.
Unlike normal wheels, this wheel was not submerged in water. Above all, it was the weight of the water alone and not the current that made it turn. This was Sagebien's first discovery. He used a falling sluice that lifted the water up high enough to fall onto the blades so that its weight would turn the wheel. This new technique provided a previously unmatched performance.
Sagebien increased the efficiency to 90%. It works thanks to a curved sluice located a few centimeters from the wheel, which allows the water to rise up behind it and drop back down onto the blades. And it is really the weight of the water on these blades that makes the wheel turn.
And to increase the efficiency even more, Sagebien set the blades at 45 degrees, the ideal angle, according to his calculations, to increase the wheel's performance. This is how the water from the Marne could be raised 12 meters to the Ourcq Canal.
These wheels would provide enough power to raise the water and, above all, to produce a sufficient flow to feed the Ourcq Canal and therefore the Saint-Martin and the Saint-Denis canals downstream.
Thanks to this clever invention, every second 3,200 litres of water are re-injected into the Ourcq Canal, leading towards Paris. The equivalent of 4 Olympic swimming pools every hour. This pumping station solved the problem of water shortages in the canals, but there were still many significant challenges to overcome. The population of Paris was continuing to grow. More and more goods were required in the capital. How would the engineers manage to adapt the canals to these new needs?
When they started building the canals, they were much smaller, and the boats that sailed on them were much narrower. Why? Because it's cheaper to build a small canal than a very large one.
The first boats to be built in the 19th century were very narrow. Known as flutes, they were suited to the width of the canals.
As the Industrial Revolution progressed, as traffic on the canals developed, as motorization and steam engines appeared, the barges became bigger. This meant that much larger loads could be transported. The barges were motorized, they had their own engines. They were no longer pulled by tugs or hauled from the banks. These were barges that were self-propelled.
Paris seized the opportunity to take advantage of this development.
In the second part of the 19th century, in 1876, the city bought the Canal de l'Ourcq and the Canal Saint-Denis and decided to completely modernize them.
They wanted to adapt them to the new freight, to the new industrial transport, to the new sizes of boats, the new formats. They wanted to carry things on 800-ton barges, so they had to re-widen the canals.
But these wider boats could no longer pass through the original canals, which had become too narrow. It was decided to completely change their dimensions.
There was a minister in the Third Republic called Freycinet who set a new standard, which was 39 meters.
To accommodate these larger barges, the locks would have to conform to a new standard called the Freycinet gauge, which set the length of the locks at 39 meters. They were also widened to 5 meters 20. By allowing larger barges to navigate these waterways, Paris experienced exponential economic growth.
By implementing this standard, they were able to transport much more freight, which came in particular from Rouen and Le Havre, and which could travel right up to the Bassin de la Villette.
The Bassin de la Villette developed at great speed. Its port was equipped with sophisticated warehouses to store large quantities of goods. Back then, to make the canals even more efficient, the decision was taken to remove anything that might get in the way of the boats and slow them down, particularly when passing through locks. Some locks were simply removed and replaced with larger ones. The Canal Saint-Denis went from 12 locks to 7, the most impressive being the Pont de Flandre at the entrance to the waterway, northeast of Paris.
This lock was distinctive in that it was the deepest in Europe because there was a difference of 10 meters between the level of water upstream and the level downstream, which is enormous.
This outsized lock is 10 meters tall, the equivalent of a 3-story building.
Downstream, on the Canal Saint-Denis, there are some lock gates that are 6 meters high, which are extremely impressive.
However, a lock as large as this loses a considerable mass of water each time its gates open. It's therefore difficult to maintain the same water level throughout the canal network. Here again, the engineers innovated by adding a structure parallel to the lock and changing the way it functioned.
Their innovation was to create what is called a holding pond, which means that instead of releasing the water in the chamber downstream, a large part of it was directed into a storage basin where it was kept. And then when a boat coming up, that's to say coming from downstream, arrived in the chamber, a valve was reopened which allowed the water in the holding pond to come and fill the chamber.
The objective was thus achieved. The water that would have been lost each time a boat passed through the lock was saved thanks to this ingenious retention pond. The lock still employs this system today. A technological showcase in the 19th century, thanks to an extraordinary lock, a pumping station, and widened channels, the Paris canals continued to adapt to new challenges.
Today, the canals have been widened even more. This allows for much wider locks, which makes it possible to accommodate larger boats that go up the Seine, barges that are pushed along, carrying all sorts of materials, coal and sand, etc., which is all brought in to supply Paris. Rubble is carried out and containers are sometimes brought in.
The transformation of the canals encouraged new ideas and led to new constructions. At the end of the 19th century, one bridge in particular became the symbol of this continual technical progress.
The canal was widened, it was made deeper, and then the question arose of a new crossing at the level of the Rue de Crémay. And so after various projects, it was decided to build a lift bridge, which was a technical innovation.
The Pont de Crémay is located at the intersection of the Bassin de la Villette and the Canal de l'Ourcq, northeast of Paris in the 20th arrondissement. It doesn't turn to let boats pass, but lifts with disconcerting ease, despite its 86-ton weight. Listed as an historical monument, this bridge is a showpiece of the industrial heritage of France.
When you see the lift bridge on Rue de Crémay, you say to yourself that it's both technologically outstanding and beautiful. It's a bridge that consists of a deck. That's to say, the horizontal part of the bridge which cars can drive across. There are columns at each of the four corners topped by pulleys. The chains inside these columns are used to raise the bridge.
How can you raise a bridge of this weight while keeping it horizontal? The engineers decided to use the principle of counterweights, as in an elevator. They designed 4 columns in which they placed 4 counterweights, each weighing 20 tons. The total weight was therefore the same as the 80-ton deck. The bridge was like a set of scales. And more surprisingly, the engineers found a revolutionary way of setting it in action.
By applying 3 bars of pressure, that's to say the pressure of tap water, you create an imbalance which allows the bridge to be raised.
A simple trickle of tap water can create an imbalance in one direction or another and thus lift 80 tons. Coming from a valve underneath the bridge, the water is injected into the hydraulic jacks, which automatically lift the structure. To lower the bridge, the jacks are emptied and the deck goes back down.
These columns are made of cast iron, and then the counterweights are lead-based. These are big structures, looking like cheese rounds, that are put in the wells and go down or up, depending on whether the bridge is being raised or lowered.
When the lift bridge is in its raised position to allow a boat to pass, pedestrians can cross to one side using a fixed raised walkway. At the time, this was the 3rd lift bridge to see the light of day in France, but the 1st in Paris. Since it was built over a century ago, its mechanism has been adapted to embrace technological advances.
In all the main bridges today, electric motors have replaced these hydraulic mechanisms, which were widely used in the 19th century, and in elevators too, of course. Today, it's the same counterweight principle that allows us to raise the bridge. We've simply replaced the driving force with electricity.
The Pont de Crimée plays a strategic role in the movement of boats, but also road traffic. It's therefore essential that it operates continuously.
If it breaks down, the impact on the road traffic is almost immediate. It's massive.
Today, it only takes a few minutes for barges to be able to pass under the Pont de Crimée and 20 minutes for large convoys. Fully remotely controlled, it still goes up and down 25 times a day. These 3 canals and their locks and bridges form an exceptional network within the French capital. A priceless heritage that's been part of the Parisian landscape since the 19th century.
It's been designed as an element that has to stand the test of time. It's an element that will last and that will have to keep going for centuries.
And yet, in the 1960s, the Canal Saint-Martin nearly disappeared forever. The reason for this was the reduction in goods traffic on the waterway. At the time, there seemed to be no future for it.
There was this idea that a large city like Paris shouldn't be an obstacle to this national motorway network that was being set up across the whole of France.
It was almost filled in and replaced by a huge motorway, an expressway which would link Paris to the north and south more quickly. It was an unthinkable decision for the inhabitants of this district, who were deeply attached to this age-old waterway.
A large number of associations were created at the time to save the canal.
In the face of popular pressure, the project was finally abandoned. The Saint-Martin Canal miraculously regained its appeal thanks to new activities.
Today, this canal has become a place for leisure, for tourist boats. People stroll along its banks. It's come a long way since its industrial origins.
The canals have managed to reinvent themselves and adapt to the needs of their inhabitants. At the end of the Canal Saint-Martin, between the Bastille and the Seine, is the Port de l'Arsenal. It used to be a thriving commercial port. Today it's become a marina in the heart of the capital. This port, with its 900 metres of pontoons, welcomes 1,500 yachtsmen a year, half of whom are stopping off before crossing Europe.
We have people who live on their boats and who spend a few days here with us before continuing their journey around the world. They can go right up the Canal Saint-Martin to the Bassin de la Villette, then take the Canal de l'Ourcq or the Canal Saint-Denis to the Seine.
And in the same Arsenal basin, today's builders are following in the footsteps of those of yesterday. The architect Bernard Altabergoiti is undertaking a major transformation of the port. He's heading an ambitious project to completely open up the view from the Place de la Bastille to the Port de l'Arsenal. It's an unprecedented opening onto this basin, thanks to 3 flights of steps, which will make the canals even more accessible to Parisians.
We've enlarged the quay by 6 meters on this side and 9 meters on the other side to make it into a real place to walk. The staircase that you can see there isn't actually parallel to the geometry of the hole that we've opened up. We've shifted it to allow a view of the column as you go up. So the column is on the stairs. You go up towards the column.
A new link between the city and the Parisian canals, seen today as oases of fresh air for the inhabitants. A project that's been made possible on one condition, to remove what was built at the end of the 19th century.
There was a structure called the Bastille Bridge, which was a series of 8 very large beams built at the same time as the metro, and which connected the old Place and the metro station. Looking at them closely, we saw that these 2 structures were completely separate from one another, and that a number of beams could be removed.
But there's a problem. The subsoil of the Canal Saint-Martin contains a large number of tunnels. Its instability makes it hard to bring in a crane to lift these beams weighing several dozen tons without it collapsing. So in the end, the crane had to be installed quite a long way from the site.
It is a 700-ton crane with a reach of 40 meters. The beams weigh between 27 and 22 tons.
In a single day, this huge crane was able to clear 5 historic beams to give a new view of the Arsenal basin down below.
We removed several square meters within Paris, and we've gained a very close link with the water, with a large staircase that will descend along this opening from the Place to the quay.
To do this, the builders used methods dating back to the construction of the canals, plunging 17 steel stakes 12 to 15 meters into the ground. A totally new layout for the canals and a new way for the Parisians to discover the Port de l'Arsenal and the hidden part of the Canal Saint-Martin. The Canal Saint-Martin, the Canal Saint-Denis, and the Canal de l'Ourcq. Today, these waterways have profoundly changed in terms of their purpose, their traffic, and their operation.
The canals are a resource for the future. They were a resource in the 19th century in terms of transport and the supply of drinking water, but they are also a resource for their inhabitants, their area, for the future.
In the plans for Grand Paris and the forthcoming Olympic Games, these canals, which have become a major attraction in the capital, will play another decisive role. The development of Paris will surely turn these legendary places into a pedestrian walkway, stretching the whole length of the Canal Saint-Martin.
This canal could also be an element of urban air conditioning. Water could become a rare commodity, and as a result, the canal might find other functions and other uses in the world to come.
In the future, the Paris canals might even join up with the ambitious Seine-Nord-Europe Canal for all industrial transport.
It's a canal that's going to join up the Paris Basin and the Seine in the north of Europe. And it's going to try and link up the major European ports between Rotterdam and Le Havre. So it's going to develop transport on a European scale.
The canals of Paris will undergo even more great changes in the continuation of their legendary past. Following the path set out in the 19th century, thanks to the structures that revolutionized techniques and gave Paris an exceptional cachet.
What's fascinating when you walk along the canals is that you can be satisfied from a historical point of view, from a technical point of view, and also from an urban point of view. It's a constant example of urban renewal.
An ambitious vision of the capital's development is reflected in the history of these canals, which form an exceptional heritage in the heart of Paris.